everyone. This is Arham from Sri Venkateshwara College of Engineering, studying in the third semester in the Department of Cybersecurity. Today, I'm here with the subjects of data structure and applications with the topic pointer variables. Introduction to pointers. A pointer is a special variable that stores the memory address of another variable or a memory location. Instead of holding data directly, a pointer holds the key to access data stored elsewhere in memory. Purpose. What is the purpose of this? It helps in dynamic memory allocation, allocates memory of data for structure at runtime and release it when no longer needed. Efficient data manipulation. It can modify data directly or indirectly without copying it. It increases the performance for large data sets. It builds data structures, builds linked lists, trees, and graphs where elements reference each other through pointers. Function arguments pass memory to address of variables to function, allowing functions to modify those variables directly. Declaration and initialization. Syntax for declaration and initialization of pointers. To declare a pointer variable, we have to follow these steps. We have to indicate the type of data and the pointer will point. Example, the integer, character, or double. We use the asterisk operator. Place an asterisk before the variable name to signify it as a pointer. Here in the small example, we can see integer star pointer. This is declaring a pointer to an integer, character star name. So it declares a pointer to the character. The name is declaring pointer to the character. We have to choose a meaningful name. We have to select the name that clearly conveys the purpose of the pointer. Initializing pointers. So assigning the variables of an existing variable, you have to use the address of an operator that and obtain the memory address of a variable. We have to use this to assign the address of the pointer. To assign here, integer age is equal to 25. Integer star pointer to age. We have given pointer to age now points to the address of the age to and age. Here integer pointer is pointing towards null. Set the reminder to null to indicate it doesn't point to a valid memory allocation. This prevents the potential errors from an access identified memory. Initialization while declaring. Combine the declaration and initialization in a single statement. Declares and initializes the pointer with address of a age. Here, int star pointer is equal to and age. So we are declaring and initializing the pointer with address of age. Pointers and functions. Pass by reference. When you pass a pointer to a function, you are essentially passing the memory address of a variable that points. This allows us, the function, to directly modify the original value of the variable, enabling efficient data manipulation of avoiding unnecessary copying. Here we have given a void swap. So here we are swapping integer a is equal to 10 here, integer b is equal to 20. We are swapping a and b, so a's value will be for b and b's value will be for a. We have to pass address to a and b. Here we have given the address of one variable to another so that it swaps, interchanges 10 and 20. Introduction to double pointers. Definition and purpose, memory representation. A double pointer, as the name suggests, is a pointer that stores the address of another variable. This gives an extra layer of indirection while accessing data into memory. Imagine as an example, it is a map leading to another map, eventually direct you to the actual treasure you seek. Dynamically changing pointers, you can modify the value stored in the first pointer, effectively changing the target location in the second pointer too. This flexibility comes in handy for tasks while resizing the arrays or managing linked lists. Multidimensional arrays. Double pointers can represent multidimensional arrays by storing pointers to each row of the array in the first pointer. Dereferencing of the first pointer that the second allows you to access specific elements within the array. Declaration and initialization. Syntax for declaration and initialization of double pointers. To declare a double pointer, we have to follow these steps. Double pointer, we use the asterisk 2 times, so we indicate that with the ultimate target of variable. Again, the same examples: integer, character, double. We use two asterisk operators, placing two asterisks before the variable name to signify it as a double pointer. Integer, we have given two asterisks and a pointer, declares a double pointer to an integer, assigning the address to another pointer using the address of operator, that is AND, twice to obtain the address of the pointer. We assign this address to the double pointer. Here we have given integer star to pointer 1, that the address is stored like in AND x. The pointer 1 is point towards x, and integer 2 asterisk pointer 2 and pointer 1 we have given it equals to pointer 1, where pointer 2 points to pointer 1. So it is a way of calling the pointer 1. Dynamic memory allocation with double pointers, allocating memory to the pointer and freeing memory allocated for double pointer. So allocating memory for the first pointer, we use malloc allocate space for the size of the pointer, typically using the size of. In the bracket, we give the size of whatever we want to point towards it. Allocate memory for the target data. This depends on what the first pointer should point to. For example, if it points to an array, you need to allocate memory for the array elements. So here we can see that the integer is pointing and also giving the memory allocation for how much size is that in the int pointer. Allocates memory for the first pointer. Double pointers and 2D arrays. Double pointer act as row pointers. In a 2D array, each array can be considered in a sub-array itself. We can see it's giving indirect access to each element within the array. Multi-level addressing. Imagine a map leading to another map. The first pointer and the double pointer setup acts as a first map, pointing an array to row pointers. Each row pointer within the array directs you to actual elements in the specific array. Double pointers building 2D arrays with dynamic memory allocation. Using double pointers offers several advantages. It is flexible in size. You can allocate memory for the array-based runtime needs, not limited by static declarations. So it is flexible. So using double pointers and 2D arrays is quite helpful. With 2D arrays, allocating memory for the first pointer, we can use malloc function to allocate memory as the size of integer. We can write the integer size over here. Allocating memory for each row. Loop through desired number. Malloc again. Allocate memory for each sub-array. Assign row pointers. Store address of another variable. And accessing elements by using pointer and dereferencing it twice, where pointer is a double pointer, I is the row index, and j is the column index. Thank you, everyone.